Hello friends, welcome to my YouTube channel. Today in this video we'll discuss about the design of Substrate Integrated Waveguide, which is in short form known as SIW, using HFSS software. Okay, and the structures which are based upon this kind of waveguide, I mean Substrate Integrated Waveguide, these structures are known as Substrate Integrated Waveguide structure. So let's move into the HFSS software and we'll design a small SIW structure, and I will tell you each and every basic step that is required during the design of the substrate integrated structure. And keep in mind, the substrate integrated waveguide structure or SIW structure, it's a bit complex than the normal antennas, because here we have to do certain number of like here in this figure you can see there is a substrate. Okay, it is a substrate, and here you can see there are number of vias. You can see there are number of vias here. Okay, so how we can design this kind of via holes, and these via holes will be filled up with copper. All these things we'll be discussing in the HFSS window. Okay, so before moving into the HFSS window, I'll show you a small I'll just show you a PDF paper, where we can have some idea about what exactly HFSS structure, how does it look. Just look at this paper. I'll just zoom in so that you can see the structure properly. Okay, so here you can see this is this is a structure. This part is this is the top view, and this is the side view. And here this pink color one, this is the patch actually, and this gray color part, this is the substrate. Here it is clearly written, this is the substrate, and this is the copper. And this via holes, this the black color one is the via holes, and these via holes are actually filled up with coppers. And here we can see they have used 3 feedings. Forget about the feeding structure we'll design, but today in this video first we'll design a substrate integrated waveguide, where we'll discuss about the patch, the ground plane, and the via holes. So let's move into the HFSS software directly. Now you can see the HFSS window, where I have opened the project, and in this project I have just inserted the HFSS design. So let us rename this one to SIW design, because here today we'll discuss HFSS, SIW design. So I'll just rename it as SIW design. Okay, good. So we have to draw a rectangular box. First we have to draw the substrate. So let us draw, this is the substrate. I'll rename this one as substrate, and we can add the material to the substrate. This material can be, normally we can take articulate. Articulate 5870 0.5870 will get durate this is 2.2. okay, no, so we can take this articulate 2.2. okay, this 2.2 we can take this durate, that is permittivity is 2.2. just click okay, and let's make it okay. That's now we have just made it, and now we need to make its like length and width. So its length and width will be considering it is square, like 34 cross 34. So we'll assign the coordinates like this, -17, -17, and we'll start it from 0 millimeter. This one will be 34 mm and 34 mm. This height I can give 0.787. Keep in mind why I'm taking the 0.787, because this material is normally available. In the market, in the open market, we can find this material having a certain thickness which will come around 0.787. If we'll take some different shapes, I mean some different dimension of this thickness, we can take, but no issue. But thing is that when we'll go for the fabrication and measurement, then we'll face some difficulties, because it's very difficult to find some our specifics, because some limited specific, I mean some specific thickness is available in market. So better to take 0.787. So now you can zoom out this one so that it will be clearly visible. Okay, now just move the top side. Now we can make a ground plane. Now we'll design the ground plane. So let us take a box. Now we'll design the ground plane. This ground plane, normally it should be at the bottom of the substrate. So we have to give the name like this is ground underscore I can give. So I can give the name like ground plane. The structure it should be PEC. If it will be copper, then of course it should be a PEC. Apply, then okay, and then this position I have to adjust. Position just I have to make it 0, and this thickness should be minus 0.787 minus 0.787 millimeter, and apply. Okay, now you can look at the substrate. Okay, sorry, this ground plane thickness actually it should not be 0.787, it should be 0. I can take it like ground plane, normally we take 0.017, it's better, 0.017 millimeter. Sometimes some people take 0.034, but I normally take it 0.017, and this is a standard case. We can take the thickness of the copper. Okay, so now we can see where is the ground plane. This is just placed just below the substrate. Now we have to design the patch in the top side. The patch also need to be 3D, better to take a 3D shape. Just to make the patch something like this, and rename it as patch. Okay, and this should be also PEC. Make it okay. Apply. Okay, this is the PEC. All right, so this patch, this dimension, we can take the dimension like 24 cross 24. Why I'm taking this 24 cross 24? Because I remember some design that I have done earlier, so that if we take that design, it will be, we can complete this project without any hesitation. Otherwise we need to go for certain calculation and all these things. So better we can take, because here in this video our main motive is to look at the design procedure, not about finding the dimension and all these things. How we can design using HFSS. Okay, so directly I'm taking some predefined values that I have already used in my papers. So the length I have considered earlier, that 24 cross 24. So I can give the coordinates like 12 mm minus 12 mm. Then I should give it 0.787 mm, because this would be placed just above the substrate. So above substrate thickness is 0.787, so it should start from 0.787, this one. And here also thickness will be 0.017 millimeter. And this length we can make it 24 millimeter, 24 millimeter. Apply, and okay, now it's done, right? So for ease of understanding, we can just differentiate the colors. Let us make the substrate color as something. Let us make it look like gray. Okay, the substrate is this, the gray, and this piece, the ground plane, will make it something, some color that looks like copper. Good. And also the patch also will make the color which will looking like, right, which will look like no less than copper. Done. Okay, so now we can make the top view. Now we have to, now the part that comes, we have to design the wire holes. We have to design the wire holes in such a way that I'll be considering the wire holes. So let us, I'll show you the paper again, the PDF file. Okay, in that PDF file I'll show you some values. Just look at this PDF file. Here we can see, I'm just zooming in. Here you can see these are the vias. Okay, this black color ones, the via holes, and in the via holes you can see the diameter of the via is taken as to d. Okay, and the distance between two via, center to center distance between two via hole, is considered as parameter p. Here we can see what is the value of p and d. The value of p is 1 millimeter. Okay, I mean the patch. Sorry, the pitch distance. The pitch distance here is 1 millimeter. Okay, so I can take it different also. No issue, that we can take as per our requirement. And the radius here, the diameter is 1.5 mm. Here we can take a different diameter also, no issue. But in my case I'll be taking something different, no issue. But keep in why I just showed you this figure, that just keep in mind the diameter. When we are designing a wire holes, two things are very much important. We need to check what is the diameter of this wire and what is the pitch center to center distance between two wire holes, two consecutive wire holes, and that distance is normally known as pitch. That is known as pitch distance, and that is denoted as p. You can denote it in any variable, no issue, but I have taken p as it like p that stands for pitch distance. Okay, so let's now move back to our HFSS software. This is the HFSS window again. So to design the wire holes, we have to take cylinders. So just take one cylinder. Okay, just draw a circle, something, just draw. Let us say we have designed something, no issue. Sorry, just better I save the system, save it in the desktop. HFSS SIW. Okay, close it and I'll open it. Okay, now I got it. So now let us draw a wire hole. Let us take this cylinder. This is the radius. Okay, and this is the wire. We'll rename it as wire. Okay, wires. Wire, and this parameter, I can make it anything. I can make it anything. Okay, so that's not required. At this moment this is not required. I'll just make the name, that's enough. I can make the color also not required, because I'll tell you why I'm not using the color at this moment. This is the wire. I just need to adjust its position. So I have calculated it such a way that the position should be, the wire position should be like let us minus 11, and it should be 0. Radius of this wire, I'll take it like 0.5 mm, and the height of this wire, it will be same as the height of substrate. Okay, that will be 0.787 millimeter. Done. Okay, now we can see the wire is placed over here, right? So now we need to check how many wires normally we are going for in this design. So once it is done, so now the important part that comes, now we have to make some other wires also. You can see, as you saw in the previous paper, there will be some wires in this line, along this line, and some wires will be along this line. Again, it will be covering all 4 parts, right? So how to do all these things, that I'll show you right now. So right click, edit, in the right, duplicate along line. Now you just click at the center and move this side. Okay, just put the tab and make all these things 0, then click OK. Then we need how many numbers? So if we'll move in this way, we need around let us say first I'll put around 10 numbers and put OK, but still it is not completed. We need 2 more. Okay, so I need to right click, edit, arrange, so duplicate along line, this like this, make it 0, then you make it 12, enter. So now it is done, right? Similar way we can do. Now we can choose this one. You can see if this is placed in the line, yeah, it is done very perfect way. So similar way we have to do this bias in across all directions, like in all sides we have to do this bias. Similarly, how we can do, just select the wire, zoom in again, zoom in, right click, edit, duplicate. You can right click here, edit duplicate, or you can select this one, right click, edit, duplicate along line, click here, just put it here, make it 0. We need also again 12 numbers. So once you click, it is done. Similar way, now we have to select which is this one. Again, we have to do it this way also. So right click, edit, arrange, so duplicate along line, just zoom in, click at the center. Yeah, keep in mind here you have to click at the center, then move right, then this in the bottom you can see all these coordinates need to be made 0, then enter, then 12 numbers, enter. Oh, we did a small mistake. So where is the mistake? You can see that we have placed, we got the wire holes, but we can see the distance between these two center to center distance between two wires is more than the previous case. So how we can change it? We can now see it's also a good thing that some error happened over here. So when some error happens, some mistake happens, how to correct that one, that is also important trick. So here we can see, here we can just double click over here. We can see here it is shown the vector is, sorry, this is not the case here. Here we can see, just go on this duplicate, you can see the vector is here also 2. Vector, I think some mistake here. Actually you can see here we have given the vector, we have given, you can see the vector we have given 3, but it should be 2. The moment I will make it 2, we can see that will make everything will fall in place. Now everything came, previously it was like this because the vector was 3. So now the vector is 2, 3, vector 3, vector 2, vector 3, vector 2. This is the way. Okay. So now what we need to do? We need to do, we left to be done in 3 cells. We have to do in another side also. So click this one, then just zoom in. Click this one, right click, edit, duplicate along line, click it here, just move in this way. Now carefully check here, it should be -2 because the vector is 2, and as we are moving against the axis in the opposite direction of the axis, so it is -2. Okay, so enter, we need 12 numbers. Now it's done, all done. Good. I can minimize this one. Now also some other things also required. So what is required right now? Let us say I will arrange the feed from this end. Let us say I'll arrange the feed from this end. Okay, I'll just take a feed line. So let us take a rectangle, make a fill line over here. So this I can rename is that feed fill line. Okay, the structure, the position, I'm not sure the position is wrong. The position should be because the feed line should be along with the patch. So patch z axis, the z coordinate of patch and the z coordinate of feed should be in the same plane. So I have to make it 0.787 because it is just above the substrate, right? Good. So now the field line is done. So what is the width of this field line I have taken over here? Okay, better. I'll take it 2.33. Normally for 50 ohm, we used to take it 2.33. Okay, so it should be, I can take it like 2.33 by 2 will be 2.33 divided by 2 will be 1.165 minus 1.165 mm. Apply, then okay, done. Right. So what we can see, when we have the field along this line, so we should not need these two wire holes. These wire holes need to be removed, because if there will be two wire holes over here, of course no signal will be passing through it. Signal cannot pass through this because there is the wire holes are here. Okay, so we have to remove these two wire holes. So where is two wire holes? Now how to search? Just click here and keep down, keep. You can see in the figure, you can see the figure where the pink color is moving, and we need to remove these two. So just keep on changing. Now you got it here. Okay, somewhere. Okay. Okay. Move. Keep on moving. You can use the arrow, scroll arrow. Okay. Keep on moving. Done. Now this also need to be removed. So once it is clicked over here, just keep delete. In other way also you can do. Okay. In other way also, now it is not possible. In other way also you can do directly. You can choose by using your mouse pointer. Then also you can do. So now it is done. So we can see that every time we have to assign the material or something, so better we can unite all these wire holes. Click here and select all these wire holes. Select all these wire holes. Select all these wire holes, then you can unite. Done. But thing is that in these cases, what we normally we have to do, we have to place some copper inside this. These wire holes need to be filled with copper, but we cannot make it directly copper. Okay, so what we can do is we have to remove some portion, because if we now I'll just save it. Now I'll save it. Now if I check, you can see now if I check this simulation and validation, it will show boundaries analysis, boundaries and excitations. Okay, I'll show you where the problem will face. Okay, once we'll face the problem, then we'll solve the issue. Now we'll assign the excitation. When you will go for the excitation, just make it, then you make it YZ axis so that you can easily see where is the axis. Okay, then you just go for rectangle, 2D rectangle, just draw over here. Okay, and at these positions, if you have any doubt, you can check the feed width as minus whatever these positions. You just copy these positions. You can take these positions, and make it 2.33, and this is 0.787 mm. So it's gone. Okay. It should be at the edge. The edge is nothing but 14. Sorry, the A was substrate was 30. It should be 17, because it should be placed over here, so it should be the substrate at the edge of the substrate. So edge of the substrate we can make it 17. Okay, apply, done. Okay, see, all these changes already I have the information, but I'm doing so that when you, because the way I'm doing that, I'm finding some mistake, again I'm solving that mistake. So how we are planning to solving these issues, that will help you actually. Okay, so anyway, so this is the rectangle. Field line should be uh, the field line should be just a moment. Okay, the field line, it should be 0.017 mm, so that now you can assign, you can now assign PEC to the field line. Now it's done. Now these are the wire holes that I will talk about what to do with the wires later. So this is the rectangle. So this is the rectangle. See, already I know there will be some error. Okay, still I am doing. Assign excitation, go to the long foot. Next, then use new line. Just click over here and make it 0.787. Finish. Now you can check the excitation is done or not. Now it is showing the excitation. Just there is a little mistake in the excitation. I have to, no issue. And I click this right, assign excitation long port. Next, new line, click here, 0.787. Now you can see, if we just click over here, if you click on the excitation, you can see that it is properly, the excitation is given. So one thing also you need to do over here is, yeah, this is the rectangle and this is the wire, this is the field line, and we can see this the field line and this patch both need to be united, right? Because that is nothing but a single structure. So you can see now it is, there is no, previously you can see there is, we can see there is a line so that it is not connected, and now once we unite this, it will look like this. There's no line in between, right? So now we need to check. Now we have to assign, now we have to check. Some errors will come. I'll show you the analysis setup. Actually this wires, these wire holes actually need to be copper filled. Okay, so how we can make it copper filled, that I'll tell you. So first make a copy of these wires, just make copy of these wires. Okay, once this copy is done, what you need to do, remove some portion, because we have to remove some portion from the substrate. Select the substrate, select some wire, and now you go for remove. Now you can see it is removed. Okay, but already we have some things and that need to be copper. Just make it PEC, perfect electric conductor. Okay, so now it's done. So now what we need to do, we need to design the radiation box. So to design the radiation box, go for here, now make radiation box, rename it at, it should be air, or we can make it vacuum. Better you can make it air, it should be filled with air, and box should be radiation box. It should be radiation box. Apply, then click OK. So now your radiation box is done, but thing is that you have to check its dimensions. Let us make it a big radiation box, minus 40 mm, minus 40 mm, 40 mm, minus let's say minus 5 mm, and it should be like 80 mm, 80 mm, and here also I'll make it 40 mm. So this is the box that is designed, and once this box is designed, click on the box, right click, assign boundary. In the boundary you have to assign like radiation, because this is the radiation. So assign radiation. Click OK. Now you can see whether it is assigned properly or not. You can see the boundaries over here. Just go up to the left side, and here you can see the boundaries, the radiation box. Once you click it, it will show like this, so that you are confirmed this is the radiation box. So anyway, why our design process is not yet completed, so we can, once you have done that one, you can hide this radiation box for each of design. We can just uncheck that one so that it will be hidden. Now we have to make a small slot over here, because we need to know that how the antenna will be resonating or something will happen. For that purpose, we'll just make a small slot over here. Just take a rectangular block box. Okay, just make a something rectangle, and this rectangle, like, you can write it as this slot. You can write the name as slot. Okay, you can assign here. Let us see the width will give like something in, we can give some size. Okay, I think there is some mistake. Let us delete this one. We'll design the rectangular box properly. Okay, so this is the actually feeding purpose. Okay, this port. So always give name, okay, so that it will not be an issue. So this slot, you can give your name like you can make it in the x-axis. So this is the x-axis, this is the y-axis. X-axis, our design should be like, say, -1 mm, and this is -6. Okay, and this size should be 0.787 millimeter, and this should let this 2, and this z should be 0.017 millimeter. Apply. Okay, and this is the slot actually, and we have to remove this slot from this patch. So what is the patch? Now this is the field. Actually, this name now it is showing field line. There is a reason, because the way we combined it, so but it is showing unit. So how to make it so that it will look properly? Just make the patch as the PEC. Now you can take the patch, then select the field line, then you unite so that it will also patch properly. Okay, and in the patch, we have to remove the slot. So first select the patch, then select the slot, then go for removal, so that we can see there is a slot, right? So almost everything is done. Now we have to just cross check. So first, this is the radiation box, which is air. This is the substrate, which is attitude. This is the PEC ground plane. This is the patch on the top side. This is the wire holes. Wires is the PEC, and this is the substrate. You can see the substrate is actually the whole one. There's the holes, and this is the port, that is the excitation is given. So this is the port. Actually, if we select here, it will show the port properly. Now we have to go and do the excitation. So before moving doing the excitation, we have to go to the analysis. In analysis, add solution setup. In solution setup, we can give some frequency. Let us give it around 8 gigahertz. Make it. Then in the solution frequency, solution setup, add frequency sweep. We can give like a step. We can give it, let's say, from 5 gigahertz to 10 gigahertz with a step size of, let's say, 0.1 gigahertz. Okay, this we can make it fast. Then okay, now we have to save it. Now I can say that I guess there will be no error. We can say, yeah, now we can see everything is ticked, there is no error. Now let's simulate this one. Okay, if we'll simulate this one, it will take some time. Okay, I believe it will take not more than 2 minutes. So let's wait. Or if you are getting bored, I'm telling you, in between, I'm telling you some informations. Like as we can see that every time we design the radiation box or we design this substrate, you can see here everything we have given these numbers like 1734. So instead of giving the numbers, also we can use some parameters. How to use the parameters? Sometime in the coming video, sometime I'll make a video about assigning parameters in HFSS. That will be much helpful for you people, because if this is a small structure, it's not a big issue to use directly these numbers. But when we will go for a bigger, complex, very complex structure, then we have to take the help of the parameters. Okay, means just like I will take a parameter x that I will consider as the length of the patch. I'll take another parameter y that is nothing but the width of the patch. Something like this for radius of the wire holes, height of the wires, everything can be taken as a parameter. And if you take a parameter actually for moving from one place to another place, finding a certain position, making different kind of modifications can be done easily. And that is actually advanced case of advanced design steps of HFSS. But as you are a beginner, you are starting, you start with the numbers, no issue. In coming video, some video definitely I'll show you about the parameter, how we can take the parameter. And this parameter will actually be helpful when we'll go for the parametric analysis, like tuning. Let's say we have designed this antenna and this antenna is not properly working. Let us change its slot, or let us change its length. So if we have taken a parameter, those parametric analysis we can do. Let's say I have taken the length of the patch like x equal to 2 mm. The antenna is not resonating. Then I can change the x value from 2 to 8. Okay, I can. There is some certain technique is there. Some steps are there. We have to follow these steps where we can assign the parameter, let's say x, and we can keep the starting point and ending point, let's say from 2 millimeter to 8 millimeter. We'll give a step size. So the system, once will simulate, the system will simulate all these things, and finally it will give the different results. Anyway, in the meantime, our simulation has been completed. We can move to check our results. To check the results, click on results, right click, go for models. I don't know what kind of result it will give, because we have not followed anything properly. Yeah, something it is showing some, yeah, it's not regenerating properly. There is a chance why it's not regenerating. To make it regenerating properly, we have to do little modification that I'll show you how it will do. The matching is not proper actually, so we can enhance some matching. Inset matching field, we can go for the inset matching field. Just take the rectangle. Okay, just make some matching. Okay, so this box we can 0.787. So you can take like 0.5 mm. Z should be 0.017 mm. Apply. It looks like this. Then we can copy this the box. Then we can copy this one. Then here in this copy, we can just make small changes, like this one. We can make it 1. We can make it 0.5. I got it over here. These two we can combine. These two we can combine like this. Okay. Now what we can do? We can just take this patch. This is the patch. Now we can remove these portions. We can remove. Okay. Now it looks like a proper patch. So let us simulate and see the results. I'm not sure whether it will give the proper result or not, because my intention was just to show how to design. I have not taken any specific values, just reminded some values and started designing. Anyway, I believe now it may give some good results. Let's go and play with it. bias. Well, in between our simulation has been completed. Let's just check result. Yeah, now you can see that it's giving some good results. Okay, so it is resonating at certain frequency and giving a band. Anyway, also we can check its radiation pattern. Just before checking the radiation pattern, we have to right click here, insert far field setup, infinite sphere. Just make it 180 to 180, and okay. Then result, create far field report, radiation pattern, gain phi, gain theta. Then make it dB. Then phi 50, frequency 8 gigahertz. Now new report. You can see this is the radiation pattern. This for 50 and for 590. This is the radiation pattern of 590. So friends, I think you have enjoyed this video, and something you must have learned, I'm sure. And if you have any doubt, you please drop your queries. I'll try to answer it out. Or you find any or in case you find any difficulty in understanding also, please ask me so that I can improve myself in the coming videos. And those people who have seen and who have already some experience in HFSS, and if you have some suggestions for me, please drop your suggestions so that I can improve my video in the next time. So guys, I'm very much thankful to you people for watching this video. And if you feel that this video is helpful, please like, drop your comments and share, and please subscribe my channel. That will definitely encourage me to do more videos uh, for antenna and filter using HFSS. So please subscribe my channel, and thank you very much for watching this video. The next video I'll upload very soon. Thank you very much.